In one of our series, we look at gears in general, which is how these mechanical gear sets are manipulated to get the desired motion as per requirement. Finally, we ended up looking at the type of gearboxes that we have today in industries. In this series, we will be looking at Spur Gear. The way these gearboxes are designed will be looked at, and their applications. It is no longer new that gears have been around for centuries and are still an essential part of our daily lives. These gears are used in everything from automobiles to trains to clocks and watches. Gears are mechanical components that are used to transmit power from one shaft to another. And examples of such are spur gears.
This gear comes in cylindrically shaped tooth-form component. And just like you said earlier, spur gears are used in industrial plants to transmit mechanical movements and to control speed, power, and torque. Also, in terms of cost, these simple gears are inexpensive, durable, reliable, and provide constant speed, which are usually used to facilitate day-to-day industrial operations.
Now, let's look at it in terms of design. Spur gear comes in the form of a cylindrically shaped gear, and the teeth are straight and parallel to the axis of rotation. So that said, with this teeth design there comes some ease during the gear design. This means the gear can easily be fabricated with the right tools when available.
Spur gear, or a straight-cut gears, are the simplest types of gear. This is due to the arrangement and the design of the gear teeth. These gears consist of a cylinder or disc with teeth projecting radially. Also, in terms of the teeth design itself, the teeth are not straight. Instead, it usually has a special shape to achieve a constant drive ratio that is mainly involute but less often cycloidal. However, looking at the edge of each tooth is straight and parallel to the axis of rotation.
And it is on that basis that spur gears can be further divided into three, which are external spur gears, internal spur gears, and spur rack.
Those classification has to do with the location of the teeth in the gear sets. External gears are gears with teeth cut outside the cylinder. Now, in a mechanical setting and during motion transmission, two external gears mesh and rotate in opposite directions, while internal gears are gears with teeth cut on the inside of the cylinder. So in a mechanical setup, an external gear, which will now be called a pinion gear, sits in the internal gear, and the gears rotate in the same direction. And because the shafts are closer together, internal gear assemblies are more compact than external gear assemblies. And also, internal gears are mainly used in internal gear pumps and planetary gear sets. And finally, in a spur rack, the gear usually sits on top of non-cylindrical gears. This gear set's arrangement converts rotational motion into linear motion. Such gear sets arrangements can be found in cars, in household equipment, and some industrial machines.
Now, when two spur gears are meshed together to form a gear set, the larger gear is usually known as the gear, while the smaller size gear is known as the pinion gear. So basically, when the gear is further connected to a shaft, a mechanical motion will be further transmitted from or to the gear sets.
Now, by design, when the diameter of the spur gear is large, This gear of larger diameter won't be made as a solid gear. Instead, it will be in a shape of a rim of different shapes as per design. With this type of metal manipulation, metal materials will be saved, and also, the overall weight of the gear will be less when compared to when the gears were not machined and shaped to gear with a rim.
Most importantly, on the gear weight. It is important that the weight of the gear are reduced to some extent via rimming. That is because the final gearbox is not the final load in the motion chain. Instead, it is used to either change the direction of rotation, or for speed-reducing applications. So having that in mind during gear design will go a long way in saving cost. And examples of such are setup cost and the running cost. Hence the need.
Again, on the gear design, gears come in two forms, which are gears with hub and hubless gears. A hub is a cylindrical projection on one or both sides of a gear. Hub is for the provision of a screw or other shaft attachment mechanism, while hubless gears are typically attached via press fit, adhesive, or internal keyway. With hub design, which is other than the teeth itself, this is known to come with improved stability.
Gear sets usually made via teeth with very specific geometry. And pitch is a measure of tooth spacing and is expressed in several ways, and these are diametral pitch, circular pitch, module, and pressure angle.
Diametral pitch is the ratio of the number of teeth to the pitch diameter of a gear. A higher diametral pitch will therefore indicate finer tooth spacing, and it is easily calculated by this formula, where n is the number of teeth, and OD represents the circumferential measurement. Circular pitch is a direct measurement of the distance from one tooth center to the adjacent tooth center. It can be measured by this formula. Module is a typical gear discipline and is a measurement of the size and teeth number of the gear. Gears measured in inches earn English module distinction to prevent confusion. Pressure angle is the angle of tooth drive action, or the angle between the line of force between meshing teeth and the tangent to the pitch circle at the point of the mesh. Typical pressure angles are 14.5 degrees or 20 degrees.
Again, also with gear set design comes with shaft mounting choices. This includes the following, which are keyway, set screw, hub clamping screws, split, and simple bore.
Spur Gear has a wide range of applications. These are in power transmission. Spur gears are commonly used in power transmission systems in automobiles, industrial machinery, and other equipment. They are also used in robotics. That is, to transmit power from the motor to the joints. In agricultural machinery, spur gears are used in agricultural machinery such as tractors, and are combined to transmit power from the engine to the wheels or other equipment.
Again, it can be said that spur gears are not used in cars because of the loud noise they produce at high speeds. This noise usually comes from the sound made when the teeth of the gears collide. Spur gears are however used in aircraft engines where they are superior to helical gears, and where noise is not an issue. And that is it for today's series. I hope you have learned something new today. See you at the next one.